Let's take a look at the sum and difference identity for sine. So here we have our little memory. Sine can't change signs. So we have sine can't change signs. And you'll notice if it's a plus, it stays a plus. If it's a minus, it stays a minus. So that's our sine can't change signs. So let's try that with this example. We're going to change this 19 pi 12ths because once again, 19 pi 12ths is not on the unit circle. So we're going to change it to 5 pi fourths plus pi thirds, which is on the unit circle. So now if we change this to sine of the first one, can't the second one, and then it doesn't change sign, so it stays a plus, change the first one, signs. Sine can't change signs. And now all of these are on the unit circle. Note that 5 pi fourths is just your pi fourths radians part of your unit circle in the first quadrant. It's just that 5 pi fourths is in the third quadrant, meaning that both x and y will be negative. So use your unit circle skills, plug in what those would be, and then simplify it to get an answer. And then come back to check your answer and see how you did. And there we go. So I plugged in my unit circle values and simplified it down to get that. Let's try another example. I like example 6. It's a little different from what we've done so far. We want to find the exact value of sine of alpha plus beta if sine of alpha equals negative 3/5 and cosine of beta equals negative 1/3. So let's start with our sine can't change signs. So sine of alpha can't change signs. Now we know sine of alpha is negative 3/5. And I know cosine of beta is negative 1/3. However, I don't know what cosine of alpha or sine of beta is. But I can figure it out by graphing both of them. So let's graph alpha first. Remember, sine is going to be y over r. So that means my y value should be negative 3 and my r value should be 5. So if the y value is negative 3 and the r value is 5, that takes me out to there, where the y value is negative 3 and the r value is 5. Now, notice that technically there is one other place where the y value is negative 3 and the r value is 5. Right there as well. However, it says that alpha is in quadrant 4. So that means I want this one. So I'm just going to take this one and erase it. So now I have alpha right here. And I can use Pythagorean's theorem to find my missing side. So a squared plus negative 3 squared equals 5 squared. And if I solve that out, I get plus or minus 4. Now I look at where it is. This x is a positive x because it's to the right. So I'm going to keep my positive 4. And now we can do the same thing with beta. So here I have cosine is negative 1/3. So cosine is x over r. So that gives me my x value is negative 1 and my r value is 3. So right there is an x value of negative 1 and an r value of 3. However, there's one other place where this also works. right there also has an x value of -1 and an r value of 3. So we look at what the instructions say. It says that beta is in quadrant 3. So I'm going to erase my quadrant 2, 1. And there's my triangle. Has an x value of -1, r value of 3, and it's in quadrant 3. So once again, I can do Pythagorean's theorem to find my missing side. And I look at this y value. This side is a negative y value because it's going down. So that makes that a -√8. And I'm going to move my -1 up so we can see it a little better. And now I have both triangles completed. So let's go back to what we were trying to find. First off, we wanted to find cosine of alpha. Cosine is x over r. So I go to my alpha triangle here, and I take my x value over my r value. That gives me 4/5. Then I want to find sine of beta. Sine is y over r. So I go to the beta triangle, pick the y value over the r value, -√8/3. And now I can simplify it. So multiply across. And combine because they have a common denominator. And there we go. So now that you've worked through one like that, now that we've worked through one like that, I would like you to try example 7. It's going to be very similar in that you're going to need to draw alpha and beta, complete the triangles to find out all the information you need. And we are this time finding sine of alpha minus beta. So let's do our memory trick real quick. Sine can't, stays a negative, change signs. So that's all the information you need. You need to graph alpha. Let's see, alpha is in quadrant 2. There we go. So there's alpha. You need to graph that and find the rest of the triangle. And then beta is in quadrant 3. You need to graph that and find the rest of the triangle. So pause the video, try example 7 out on your own, and then come back to check your work. Okay, so first off, I have alpha, which is y over r. There are two places where the y value is 5 and the r value is 13. But I wanted the quadrant 2 one, so I x'd out that one. And then I used Pythagorean theorem to find my x value. Make sure it's negative because it's to the left. Same thing with beta. I know tangent is y over x. So this spot has a y value of 2 and an x value of 1. But this also has the same tangent value because -2 over -1 would give me the same tangent value of +2. And because we know it's a quadrant 3 angle, I know that I actually want that one. So I did Pythagorean's theorem to find my hypotenuse, my radius, and then I just filled them in. So sine of alpha is y over r, so the y value over the r value. Cosine of beta, cosine is x over r, the x value over the r value, minus cosine of alpha, which is x over r, and sine of beta, which is y over r, and then simplified it. So that is all we're going to say about the sum and difference identities for the sine function. In the last video of the day, we're going to do the sum and difference identities for the tangent function. And that'll be your last equations you need to memorize for this section.